Greetings and welcome. This is your friendly Electric Shmoo bringing you another URLium Archon responder script. Today we're going to be building a world edit on steroids. This is effectively an Insta-Castle, textured walls and towers with little rooms at the top of the towers, just with some commands and this post wand to set our start and stop locations. And that is going to be in 350 lines of PHP. Don't worry about the linear algebra. Don't worry about the statistics. Don't worry about the geometry. It's really not that bad. So before we look at the PHP script and before we look at the functions of the mod itself, I need you to go ahead and click with your config wand on the like and subscribe and let me know exactly what you would like to see in the command section. Not the comment section, it's the command section. So with this builder script, we have a wand that's going to be used to set our start and our stop position. So that's the start and the end, and that is going to describe the line at which the base of your tower or your wall is going to be built. So we're going to set a parameter with our webcom type command. We're going to say this is a stone wall, and we're going to say the height is going to be 6. And now we just issue the wall command, and there we are. We have a unique selection, randomly chosen from a particular set of blocks. We have a mossy cobblestone towards the bottom and some cracked bricks, and we have some polished andesite at the top. And we can continue our wall with just another command, and you can see that it will freeform change even with variation in elevation. Ta-da! So I wander over here and I find myself a new location to start from. I don't want to continue the wall, I want to start a new wall. And so I'm going to go ahead and issue a clear command, webcom clear, to set my positions as starting from a new start. And I'm going to choose a different wall type, webcom type brick. And I'm going to issue a brick wall, let's say 4 height. Webcom height 4. Webcom wall. So now I can make a whole new starting position and continue from here. Insta-wall. Now remember, I didn't just say Insta-wall, I said Insta-Castle. And for our castle, we're going to need some towers, we're going to need some columns, some structures. So let's see what the tower parameters are. We're going to start with the radius and the step. So radius is going to determine the radius of our cylinder, and step is how many degrees, around 360 degrees, should it calculate a block to be placed. So you can use a large number to give you something like columns that are placed every so number of degrees around the center. So I'm going to set my new end location. That's going to be the center of my tower. And I'm going to set the height, webcom height, to 10. And I'm going to set the type of blocks to end. I have some end stone and purpur combination set up. And I'm going to make sure that flare is turned off. We'll look at flare a little later. And with those parameters set, I just want to make sure radius is set to 3. And let's go ahead and make our tower. And there we go. We have our randomly generated end stone tower with a little touch of purple thrown in towards the bottom. And if I don't like that particular tower, I just run the command again. Or I can choose a different set of blocks and say maybe the sand tower. And generate an automatic new combination very, very easily. That is Insta-Tower. Now, with the step command, we can actually use this to make multiple columns by setting the step to a significant degree, like let's say 60 degrees, so we're going to get 6 columns, and we're going to space them out a little more than 3 pixels. We're going to push them out to 5, so let's say webcom radius 5, webcom step 60, and now let's say webcom type slate. And let's step back and give it some room, webcom tower. And there we go. We can have it calculate where the appropriate circular angle is. In fact, there's enough room. I could change this to 30 degrees. Let's see. If we do 30, there should still be enough room. There we go. So now I have a sort of instant ancient ruin, or a sort of Stonehenge-like structure, very quickly constructed. And you, again, can choose what blocks you want to appear at what levels. And if you don't like the combination it came up with, you just run it again and again and again until you come up with just the right balance. Very nice. Now, I mentioned the flare and extend parameters. Flare is just what I'm describing, the room at the top of the tower, how far down from the top should the tower flare out, and extend is how far from the radius should it extend outward. So let's look at a tower with some flare. We have our center of our tower is set. We're going to set our radius, webcom radius 3. We're going to set the type to stone. It's pretty simple for us to see all of the blocks. Webcom type stone. We're going to set the flare to 5. So 5 floors from the top of the tower is where we are going to begin to extend outward and create a little room. And we're going to say webcom extend 2. It's not going to extend that far from the regular tower's radius, just 2 blocks out. And we'll make it 15 blocks high. Webcom tower. And here we can see that 5 blocks down is where it begins to flare outward, and it produces an automated procedural structure. Now, it did miss a few pixels. I think we could change the stepping and come up with a different result, but let's say I decided I don't like that and I just completely want to remove this. As long as I don't change any of my parameters, I can change my block type to air. And completely undo that entire tower. This is another little feature of the block sets, where we can choose which blocks get placed at what elevation. There, I just said 100% chance they're all replaced with air. So let's take a look at how this particular function and all of that you've seen so far actually takes place in PHP. Now, if you've seen the other videos, you know that we're using the Archon library for PHP, and I'm initializing with my config values here. So I am left with an Archon object that is connecting, and then I'm going to be processing what type of device sent this message to my script. So if it was a message, a command using webcom, then I'm going to process that mostly as input parameters. I have a clear position, I have the wall command, the tower command, and then if it is the wand, then I'm going to be using the block target as my start and stop position, and that is how I handle the actual input coming in. And we have some basic support functions for getting and setting the user preferences. When I've stored that information, it's simply storing it in a JSON config file. And down here we have the functions that are actually generating the block sequences and picking the appropriate blocks to use for that elevation. So we'll start from the beginning, and I'll go through each section very quickly, just so you can see that it's all pretty accessible PHP. First, in our messages, we have type, and that's going to be receiving the block type that's going to be pulled from a config file when we're actually generating the blocks at different elevations. And so most of these parameters all have the same input structure. I'm reporting error messages if you've missed the extra parameter to let the user know that they have missed the type or the number. We have the radius for the tower, the step for the incrementing around 360 degrees, the flare, the optional parameter for the building's room at the top, the extend parameter, which is required if you have flare. Clear is really just unsetting your start and stop positions. When you record your wand position, it's going to store the start position first, and then once it has a start position, your next click will be your end position. So every next click will be your new end position, and basically your start is shifted from position 2 to position 1 every time you run the wall command. So here we can see that I'm getting my preferences. Where do I start? Where do I stop? What height is the wall? Make sure these have all been completed. If they have, we're going to generate a sequence. We're going to run that sequence, and then we're going to tell the user that it's completed. The tower, same thing. We're getting our parameters. We're validating that all of those parameters have been supplied. Here we're making sure that if it is if there is a flare, that you have specified how much to extend that room out. And here we have create tower sequence, and again that's going to return a list of block commands that's going to be run, and then tell the user when it's done. The block section, or the wand section, is again just taking the block input information and storing it as your position. If it has an existing start position, then we're going to save this as your end position. If it was cleared or you've never set your start position, then we're going to set the start position. And then your next click will obviously be the end position. All other messages are just returned. We're not doing anything else with any other types of blocks in this script. But here we have just a simple filter alphanumeric. Get user preference, very self-explanatory. Set user preference, again, doing the same thing as unset. We're just changing what our operation is. And now, the meat of the function is create wall sequence and create tower sequence. So in the wall sequence, we have the height, the start, and the stop. Now, one thing that I could have also passed in is the block types. I've just decided to pull it from this location. Doesn't really matter. Um, but the block types are going to be pulling from JSON files. And this is going to be a list of block types with the height maximum and the height minimum from 0 to 1% along the height of that wall. Where should that block be, and how often should that block be found? We'll look at the configuration of that file in a second. But when you've set that preference, you're basically telling it which set of blocks from this JSON structure should I be pulling from. Then what we're going to do is get our delta for our x, y, and z directions. We're going to find the maximum of them and see what is the most number of steps we're going to have to take to make sure that we fill in all blocks for this line. And so for every level of height, we're going to start from 0 and we're going to go up to height, and we are going to build up a wall by repeating a delta from k to length. Again, length is the maximum length along any of those directions. And we're going to calculate the start position and a delta. It could be positive, it could be negative, but this delta is going to tell us where along that path we need to place that block. So it's going to adjust, and here I'm adding I so that this is repeated for each level of elevation. I round those numbers out for Minecraft sanity, and then here is where I'm going to get a randomly chosen block to then place in my set block command. I'm using the uset block so that it is silent to the Archon op users, and we have the ability to do things in the overworld or the nether or any other dimension that you have set. And that is just going to return a list of commands. So I just create an array and add each command to the array. Now the create tower sequence is a little more complicated. We have some optional parameters for flare and extend, and so I'm using some flags and some values to create a floor, and basically we have a for loop for the same sort of height variable, but we do need to check if we have reached the flare height and if we have triggered a floor. If we have not triggered a floor, go ahead and do that, and once we've finished making the floor, move that to a different value so that we know we are done with the floor. And if we are above the height of the flare, then we need to go ahead and return the radius of the tower plus the extension. So this will give me the inner wall of the tower and the upper outer wall of the tower by checking if we have triggered the flare, whatever we want to call that room. But basically that floor signal is going to be used here to calculate the radius of the wall. And we basically repeat this for each ring of floor from the inner radius to the outer radius. So we have this interesting do while structure that lets us loop so that we can enter floor building mode to make a solid floor at that particular height. We're calculating our sine and our cosine for our x and our z values, and our height is our y plus the I elevation. Again, here we have that get gen block to pick which particular random block we want to use for this elevation, and we add each command and return the set of commands. It is, I guarantee, a unusual instruction structure, but that lets you use this one creation function for all three parts of the cylinder, the vertical and the horizontal structure of the cylinder. And so here we have the final get gen block, the magical block picker that is going to choose from the block types. We have end stone, we have bricks, we have sand, we have slate, we have stone, and what all of these recipes are is an array with a maximum and a minimum range of where this entry should be used and what weight of value should be used in the calculation of that random selection. So if we are 50% down, then we are going to fall within this set of block selections. If we are at the bottom, we're going to fall within this range. If we're at the top, we should just get this one that goes from 1 to 80%. And so each of them has their own sort of recipe of percentages. Here's from 80% to 50%, from 50% to 10%, from 20% to 0. And this lets you intermix where and if you want to leave a gap, you can leave an error block. And if you want an entry that will undo any of your actions, just make error a set of options as well. And so this array is loaded for each of these wall and tower instructions, and they call the gen block function to ask at what height and what row are we currently working. This gives me my percentage from 0 to 100% of the height. Where in the wall am I building? And then here I'm passing in the block types. And so to do this weighted evaluation, we're going to create a list of valid block types by checking who falls within the current maximum and minimum of what we are looking at. So if I am at 50% according to this call of the function, let's say I'm at row 5 and the height is 10, then I'm going to look for any valid entries that fit within that parameter. I'm going to add their weight to a total weight, and then once those have all been found, I'm going to pick a random number from 0 to the total weight. And this gives me a random floating point value somewhere within that range. Now I want to go through all those valid blocks and see which one is it that pushes me past that chosen value. As long as the random value is greater than my sum, I want to keep adding to my sum until I find the block that matches this random selection. So if a number occupies a very large value, it is more likely to be the one that pushes your entry past that selection. So that is going to then return the block that was selected. Actually, down here, this is actually wrong. We don't want to do that. That's a bad line. We are returning the block here. um, and this is where the actual selection is being made. So that is a weighted average that dynamically pulls from different elevations. And we can see the config files are named based on the word that I saved in the webcom type command. I just say end or brick, sand, slate, stone. And so that is the script. I think this may be perhaps a bit daunting if you just think about how to make a world edit tool from scratch, but if you actually break it down into the code, it really isn't that much. We're just looking at 350 lines of very unoptimized PHP. And again, it is all available to you in the repository for public use. So here's to hoping that a few of you found this useful. Even if you don't use URLium, just the ideas that you might get from the archon functions, sending them into the game and coming up with some programmatic structures, I think that can be interesting on its own. But please do give me a like, give me a subscribe if you made it this far. Oh my goodness, thank you so much. And I very much appreciate any feedback, comments, or ideas that come back. Even bug reports. Let me know if you find any problems. I think I found a bug, but I'm not going to tell anyone until I find it because it's not really a problem. It's just a typo, and I think it's funny. So, take care, everybody. Uh, I wish you well, and I'll see you again with another example, maybe with some inventory and some game show like behavior. And take care. See you around. Bye bye.